Question B, part I. Find the maximum possible value of T1. Okay, right. So T1, let's just write down what our answer was. mg bracket 2 plus dA minus dB minus dC. So just looking at the algebra, how can we maximise this? The things that can alter are the d's. Okay, that's us moving the spotlights horizontally along their little tracks. If we want to have the biggest possible answer, we want dA to be the largest possible value it can be, and then we want to subtract the smallest possible values. Okay, so this is when we go back to the little inequalities that we were given in the question. Okay, the largest dA is 0.3, the smallest dB is 0.1, and the smallest dC is 0. Okay, so the largest dA, the smallest dB, and the smallest dC. And what that corresponds to is us pushing these spotlights as far to the left as they can go. Okay, so this one is right at this end, this one is here, this one is right here. And that's going to basically make as much of the tension as possible being taken by wire 1 and as least as possible taken by wire 2. Okay, so you could do it from that sort of physical point of view, or you could just do it sort of from the maths point of view. Okay, so when you add that up, that gives you 2.3, 2.2, it gives you 2.2 mg. That's your maximum T1. Part 2, without carrying out any further calculations, write down the maximum possible value of T2. Well, it's symmetrical, okay? So all we need to do is think about pushing it the other way. So if they were all pushed to the other end, you'd get the most of your heaviness, most of your weight being taken by wire 2. So we want basically a symmetrical picture the other end. And remember, it is symmetrical, okay? The whole picture is a symmetrical picture. These inequalities are all symmetrical. So basically we can just say, by symmetry, our maximum T2 is also 2.2 mg.